All right, this is lesson 5.1. This is part 2 of it, and a continuation. We'll add on a little bit at the end, but a continuation. And so here they give you a cosecant plus secant. They want it in terms of sines and cosines. So cosecant, hopefully you look and say, oh, that's the reciprocal of sines. I've got 1 over sine. Here I've got 1 over cosine. And then you can kind of argue about what's the simplest way to leave that answer. Well, maybe this is simple, or maybe we get a common denominator of sine, cosine. Here, sine, cosine. So the first fraction I have to multiply by cosine. The second fraction I have to multiply by sine. And I get a common denominator, and I get cosine plus sine over sine cosine. And you might argue, wait, that looks more complicated than what we started with. And in one sense, you'd be right, but we want to get these down to sines and cosines because those are more familiar functions. So that would be a good answer, or maybe even here would be an okay answer. But we want to get it down to sines and cosines. All right, one more of these. Here's secant times the cotangent times the sine. So you look at that sine and say, that's okay. I want it with sines and cosines, so I'll keep the sine. So I'll keep that one. Secant. Secant is reciprocal of cosine, so I'll write 1 over cosine. That looks good. And cotangent. Look that up on your identities. Cotangent. How about cosine over sine? This is kind of an interesting problem. So cotangent gives me that. And again, here the sine on the right, that's really like sine over 1. Look at everything that's going to cross cancel in this problem. The cosines cancel out, gives you 1. The sines cancel out, gives you 1. I have a bunch of 1s times 1s. This whole identity is just 1. So if I take a secant times a cotangent times a sine, makes no difference what angle I've got, I'm going to get 1. Okay, so that's the bulk of what we're doing in this section, is simplifying. There's one more set of identities that are called the negative angle identities. I want to explain these first looking at the graphs. And if you look ahead at the next page, we'll actually get the 3 identities. You can see the 3 identities right here. But just kind of explain where they came from first. All right, and easiest, since we just finished graphing, is think about the graphs. And hopefully you guys would look here and say, okay, that looks like the graph of a cosine function. So the question is, if I take the cosine of pi fourths, if I take the cosine of negative pi fourths, what do I get from my answers? Are those answers the same or different? How do they vary? As if you come over here, pi fourths is about here. Negative pi fourths, I'm going the same direction the other way. And what do you notice about the y-coordinates? The y-coordinates are the same. Either way you do it, and maybe remember this from your chart, but certainly from your graph, you should agree they're equal. And maybe remember they're root 2 over 2, I don't know. But for sure, the cosine of any angle, and you take the cosine of the opposite angle, they should give you the same value. So the cosine of theta, if I go to the right, and cosine if I go to the left, I get the same y-coordinate every single time. Because look, it's symmetric right here on the y-axis. So the cosine of theta is the same as the cosine of negative theta. Not true for sines or tangents. Let's scroll that a little bit. For a sine, look what happens when you go to the right. It goes up. When you go to the left, it goes down. So if I had the sine of pi fourths and the sine of negative pi fourths, what would happen? Sine of pi fourths, I get a positive answer. Sine of negative pi fourths, I get the exact opposite. I get a negative answer. So we'll get that idea. We'll say the sine of theta, it's the opposite of the sine of negative theta. And likewise for a tangent graph. Look, when you go to the right, it goes up. You go to the left, it goes down. So hopefully just looking at those 3 graphs, these identities kind of make sense. And our identities are right here. So if I have a negative angle and I take the cosine of it, it doesn't matter. It's the same thing as just taking the cosine of the angle. If I've got a negative angle for a sine, it gives me the exact opposite values I would have gotten for the regular sine. And again, I can write it like this. Or I can write the sine of negative theta. I can put the negative out here in front too, can't I? Because I'm just multiplying both sides by -1. And think of the opposite, I'm sorry, the negative sign as meaning opposite. So the sine of negative theta is the opposite of the sine of theta. The same thing for tangent. Tangent of theta is the opposite. Oops, we need an extra negative in there somewhere. So let's change that one right there. The tangent of negative theta is the opposite of the tangent of theta. If you get into class tomorrow, you can look at your book. There's a nice summary on page 188 of all these identities. These last three, I mentioned them. We don't use them quite as much as the first three sets of identities, but they'll come up once in a while. All right, let's put this all together and see if you can sort this out. So here's a matching. We got 5 on the left. We've got to match them up with 5 on the right. Can we match these up? Well, we just did the negative one. So the cosine of negative x, we know that negative doesn't matter. So it'd be the same as the cosine of x. So 3 we'll put with e. All right. Anything else just jumping out at you? Don't you know tangent? Let's see. What's tangent? Isn't that sine? Isn't that one of our identities? So 2 would go with d. Or likewise, cosine over sine. That's just the opposite, sine over cosine. Cosine over sine, isn't that cotangent? So just kind of putting these all together. So 2 goes with d, 1 goes with b. All right, not too much left. Tangent squared plus 1, that was one of our identities. Tangent squared plus 1, right there. That was the secant squared. And our final one, oh, our classic Pythagorean identity. What's the sine squared plus the cosine squared? It is 1. And so there'll be questions like that where they mix all your identities together. You've got to keep them straight. And this was a nice practice on that. So guys, that completes the first section. Some nice ideas in here. We'll practice this in class tomorrow, and then we can move on to section 2 the next day. But we can take care of this in one day, so it'll move a lot quicker than chapter 4. That's it.